You might remember learning about a terrifying hole in the atmosphere that nearly did us in back in the 1980s. Or maybe you've never even heard about it. Nowadays, educators often skip the topic altogether because that ozone hole is filed away under problem solved. But back when the hole was at its largest, scientists were really freaking out. Without an intact atmospheric layer acting like a giant beach umbrella blocking the sun's radiation, we were all gonna fry, they said. An emergency meeting was convened in Boulder, Colorado. Scientists gathered from all over. The leader of the conference sought a volunteer to head up a mission to the South Pole, where the hole was most pronounced, to study the phenomenon. For an uncomfortable second, no one volunteered. Then, Susan Solomon, a young computational chemist who spent her days creating complex atmospheric models, raised her hand. She wasn't really a fieldwork scientist, but she knew her way around a spectrograph, which would be the critical instrument for the South Pole research. "I'll go," she blurted. The reaction from the crowd, a dismissive shrug followed by titters, was not unfamiliar. Earlier that day, she'd presented her own novel theory on why the ozone hole had opened in the first place. But no one had seemed particularly convinced or impressed then either. She'd based the theory on a decades-old study of chlorofluorocarbons, CFCs, chemicals found in things like refrigerants, hairspray, and aerosol deodorant. The study had stated that CFCs could very slowly destroy the ozone layer. Susan had zeroed in on chemical reactions to answer two questions. If CFCs were used widely, why was the ozone hole appearing only in the spring and summer? And why was the hole centered over Antarctica? She pinpointed the exact altitude of maximum loss and recognized the preponderance of clouds was a clue. Susan posited that there were two things helping CFCs destroy the ozone layer. For the necessary chemical reactions to happen, the CFCs needed sunlight to break the chemical compounds apart, since UV radiation is one of the few things that can undo these molecules' bonds. They also needed something to sit on, like nice, tiny ice crystals and all those gathering polar clouds she'd noticed. Susan hypothesized that in these perfect conditions, CFCs were breaking apart and releasing chlorine, which was destroying ozone, which then released more chlorine in an ever-accelerating, terrifying loop. It was ridiculous to her audience. All men. And the bit about the clouds, that was practically heretical, as Susan recounted. And now, this woman with the crackpot theory wanted to lead the expedition to the South Pole? Well, yes. And 4 months later, she did.